Hi guys, in this video we are going to solve population growth and population decay problem. So let's start with the first problem. Population growth problem. The initial bacterium count in a culture is 500. A biologist later makes a sample count of bacteria in the culture and finds that the relative rate of growth is 40% per hour. Find the function that models the number of bacteria after T hours. What is the estimated count after 10 hours? And letter C, when will the number of bacteria be 3,500? Okay, so let's solve this. Letter A, we know that the function that represents the population growth is denoted by A of T is equal to A sub 0, or the initial number of bacteria, E raised to kt, where t is time and k is the relative amount of, or rather the relative rate of growth. Okay, so we are going to find, so the initial number of bacteria is 500, therefore that is A sub 0. We have 500 and we have the relative rate of growth of 40%, so that is k. So 40% in decimal, that is 0.40. So therefore, the model that will represent the number of bacteria after T hours will be A of T is equal to A sub 0 is 500, so 500 E, then ang K is 0.40, so 0.40 times time. So this is the answer sa letter A. Okay? How about letter B? So what is the estimated count after 10 hours? So to answer letter B, we are going to use this model. So we have to find A of 10. Okay, simple substitution, we have A of 10 is equal to 500 E raised to 0.40 times 10. Okay, and that is approximately, using your calculator, you just input this directly, it will give you 27,299.08. Okay, so after 10 hours, so the number of bacteria will be 27,299.08, or you can approximate this as 27,299. Okay, how about letter C? When will the number of bacteria be 3,500? So in this item, the given is A of T. A of T is equal to 3,500, and we have to find the time that the number of bacteria be 3,500. So same, gagamitin din lang natin itong model natin na A of T is equal to 500 E raised to 0.40 times the time. So yun nga lang, we have A of T here, which is 3,500, and we have 500 E raised to 0.40 times time. So we divide both sides by 500. Okay, so this will be cancelled. 3,500 divided 500 is 7, is equal to E raised to 0.40 times time. Then to solve for T, we have to take the natural logarithm, so ln 7, and ln E 0.40 times time. Then that will become ln 7 equals, using log logarithm, 0.40 t will become here 0.40 times t, then ln E. Then we have ln 7 is equal to 0.40 t, because we know that ln E is equal to 1. Then to solve for t, divide both sides by 0.40, and that is ln 7 all over 0.40. So rather without t, sorry. Yan. So divide both sides by 0.40. So t is equal to, just use your calculator, ln 7 divided by 0.40, 4.865, approximately 4.865 hours. Ibig sabihin, after 4.865 hours, the number of bacteria will be 3,500. Okay, let's have the second one. The population of the world in 2020 was 7.75 billion, and the estimated relative growth rate was 14% per year. So if the population continues to grow at this rate, when will it reach 122 billion? Okay, as you can see in the problem, we have to find the time. Okay, time is required in the given problem. So let us first identify the model. So what is the model that represents this problem? So as you can see, 7.75 billion can be assumed as the initial. So that is 7.75 billion. Then the relative growth rate is 14% or 0.14. And then we have 122 billion, that is A of t. So 122 billion. So how we are going to find the model in this problem? So the model will be A of t is equal to the initial 7.75 e raised to 0.14 times the time. So this is the model that we are going to use to solve the problem. So let us solve. Just substitute all the given information here in the model. So A of t is 122 billion, then 7.75 e raised to 0.14 times the time. Okay, so we do not put 00 because it will be cancelled already, because all the units here are a billion. So then we have to divide both sides by 7.75. Okay, 7.75. So I suggest na wag munang i-compute ito, use as is na lang muna para mas malapit sa exact yung ating makukuha sagot. So therefore we have cancel this. So 122 over 7.75 equals e raised to 0.14 times the time. Then we have to move here, take the natural logarithm, that will be ln of 122 divided by 7.75 equals ln e raised to 0.14 times the time. So copy this. So we have 122 divided by 7.75. Then we have 0.14, bring down the exponent, times the time, ln e. So we have ln times 122 divided by 7.75 equals 0.14 t, because ln e is equal to 1. So to solve for t, divide both sides by 0.14. Okay, so cancel. Therefore, t is equal to ln 122 over 7.75 all over 0.14. So just input this in your calculator. It will give you 19.69. 19.69. So the unit is years. Okay, so this means that after 19.69 years, the population will be 122 billion. Okay, let's have number 3. We have a population decay problem. A colony of bacteria decays so that the population t days from now is given by n of t equals 1000 times 1 over 2 raised to t over 4. What is the initial number of bacteria? How much will be present in 8 days? And what is the half-life? Okay, so let's solve first letter A. So as you can see, we are going to find the initial number of bacteria. This means that time is equal to 0. So if you are already familiar with this kind of problem, you can see that 1000 is already the initial number of bacteria. So the answer in letter A is 1000. But we have, I'm going to show it to you bakit naging 1000. So we have the given function or model n of t equals 1000 times 1/2 raised to t over 4. So we have n of 0 is equal to 1000 times 1/2 Then ang time is 0 over 4. Therefore, n of 0 is equal to 1,000 times 1/2 raised to 0. So we have n of 0 is equal to 1,000 times 1/2 raised to 0 is 1. So therefore, n of 0 is equal to 1,000. So the initial number of bacteria is 1,000. Okay, so letter B. How much will be present in t days? So we have time equals 8 days. So we have to find n of 8. So we have 1,000 times 1/2 raised to 8 over 4. So we have n of 8 is equal to 1,000 times 1/2. 8 divided by 4 is 2. So we have n of 8 is equal to 1,000 times 1/2 squared is 1/2 times 1/2, so 1/4. Therefore, n of 8 is equal to 1,000 divided by 4 is 250. So there are 250 bacteria after 8 days. Okay, so how about letter C? What is the half-life? Half-life is the time in which half of the bacteria remains. So, kailan daw magiging half yung number of bacteria? So, as you can see, if you are familiar with the model, so the denominator in the exponent is the half-life, 4. So, I am going to show you kung bakit siya 4. Okay. So, ibig sabihin kung half-life, kung ang original number of bacteria is 1,000, ang ating half-life is, nagagamitin is 500 kasi kalahati yun. So, substitute lang natin dito sa formula. We have 500 is equal to 1,000 times 1/2 t raised to 4. So, divide both sides by 1,000. So, divide by 1,000. Divide by 1,000. So, this will be cancelled. 500 divide 1,000 is 1/2 is equal to 1/2 raised to t over 4. Same base, so the exponent of this is 1, right? So we can equate the exponent. So we have 1 is equal to t over 4. Cross multiply. So 4 times 1 is 4. So therefore, t is equal to 4. So the half-life is 4 days. So, okay, it is always the denominator of t is the half-life. Kung ang model ay sa ganitong form. Okay? So ganyan lang mag-solve ng population growth and population decay problem.